In this training, you will learn how to safely change over heat exchangers. We will explain the key hazards of the process and teach you how to design an interlock sequence that eliminates these hazards. Heat exchangers heat up or cool down process fluids and gases. They transfer heat between the process medium and a heating or cooling medium. A heat exchanger is used to heat up hydrocarbons. A flow of hot oil or steam heats up the hydrocarbons that flow in the opposite direction. A heat exchanger can also cool down hydrocarbons using water, glycol, or ammonia liquid and a heating or cooling medium. Heat exchangers are widely applied in process plants, either to preheat or reheat process fluids, or to pre-cool or recondense them. They are commonly found around fractionating columns. Reboilers boil the liquid from the bottom of the column. Condensers condense the gases from the top of the column before injecting them into the column again to increase the yield of the column. Heat exchangers are a part of the core process, which runs nonstop between shutdown intervals. But the continuous product flow contaminates the exchanger and periodic maintenance is required. Therefore, heat exchangers must be maintained in a live process. Multiple heat exchangers are installed in parallel, so one can be maintained while the other takes over the process. Changing over between heat exchangers requires strict adherence to procedures to avoid hazardous mistakes. Heat exchangers mostly work in parallel. When one requires maintenance, a spare unit is put online. This spare unit must be online before the other is isolated. If both would be isolated, the process flow is blocked, likely leading to an explosion. When an outlet valve remains closed, the flow is also blocked. Pressure builds up rapidly, causing the heat exchanger to explode. Pressure safety valves quickly relieve overpressure. For every online heat exchanger, relief capacity must be available. If the PSV is blocked, overpressure cannot be relieved. Pressure will build up, and the heat exchanger might explode. Isolated heat exchangers contain residue or hydrocarbons through a leaking inlet. When the coolant flows, while the process flow does not, the residue cools down and solidifies. Resulting solid particles damage or constipate the heat exchanger or adjacent equipment. When the heating medium or hot process medium flow starts, while the cool medium does not, residue inside the exchanger heats up. Vapor builds up, pressure increases rapidly, and an explosion might occur. Heat exchangers are connected to pressure relief capacity. Each exchanger might have its own PSV. Multiple exchangers may share a single relief valve or a system of parallel relief valves. The same goes for rupture disc overpressure protection used instead of pressure safety valves. When PSVs are not equipped with block valves, they cannot be included in a sequence. In case of multiple single PSVs, their block valves must be interlocked. The changeover should commence with the opening of the spare relief valve. The final step in the changeover is the isolation of the other PSV. When heat exchangers share a single PSV, they are interlocked in the same way. The changeover should commence with the opening of the spare relief valve. The final step in the changeover is the isolation of the other PSV. When heat exchangers are connected to a system of parallel PSVs, that system should be interlocked independently to ensure relief capacity. There's no direct link required with the heat exchanger interlock sequence. When switching over heat exchangers, flow capacity must be guaranteed. Avoid that the product flow is blocked and pressure builds up to dangerous levels. Therefore, never isolate both together. Interlock the process flow valves, so the spare heat exchanger must be put online first. Open the spare exchanger's outlet valve to avoid pressure building up. Then, open the inlet valve so the process flow can pass through the heat exchanger. Now, close the other exchanger's inlet valve. Then, close its outlet to complete the isolation. When the heating or cooling medium comes from a shared feed line, this flow must be included into the sequence. Starting up the spare heat exchanger, you open the process outlet first, then open the medium outlet, continue with the process inlet, and finally, the medium inlet. Shutting down the heat exchanger, you close the process inlet first, then close the medium inlet, then the medium outlet, and finally, the process outlet. When PSV block valves need to be included, always ensure online relief capacity. You start by putting the spare relief valve online. At the end of the switchover, the other PSV can be isolated. The final interlock configuration depends on various factors of the process. Make sure to incorporate all relevant valves to ensure safe operation. Always ensure online relief capacity. Make sure that the process flow is never fully blocked. And avoid when one of the two flows is jammed, causing overheating or freezing up of that medium.